Okay, welcome to today's tutorial. In this video, we're going to look at hybridization and how to determine the hybridization of an atom. So, what is hybridization? Hybridization is the mixing of atomic orbitals. It is the mixing of atomic orbitals of the same atom to form new equivalent orbitals called hybrid orbitals, right? It is the mixing of atomic orbitals. An orbital is simply a space or a region where electrons are found, right? So it is the mixing of atomic orbitals of the same atom to form new equivalent orbitals called hybrid orbitals. And this is what is responsible for bond formation in molecules, right? So for instance, we have s orbital and we have p orbital, which is divided into px, py, and pz, right? This is the p orbital. This is s orbital. So when we mix these two orbitals of the same atom to form a new orbital, that mixing is known as what? Hybridization. That process of mixing them is known as hybridization, right? And why we mix, the reason for hybridization is to get a maximum separation of electrons, which will in turn give that molecule stability, right? So the main purpose for hybridization is to get a maximum separation of the electrons, a maximum separation of electrons, so that the compound or the molecule can become more stable. So again, hybridization is the mixing of atomic orbitals of the same atom to form new equivalent orbitals called hybrid orbitals. And the reason for this is to get a maximum, or is to attain a maximum separation, of what? Of electrons, right? So like I said, hybridization is what is responsible for bond formation in molecules. It is also what is responsible for the shape of a molecule. It is responsible for the bond angle, and also it is responsible for the bond strength in an atom or in a molecule, right? So again, hybridization is the mixing of atomic orbitals of the same atom to form new equivalent orbitals called hybrid orbitals. An orbital is simply a region in space where electrons can be found. Basically, we have four types of orbitals in chemistry. We have the s orbital, which is spherical in shape. We have the p orbital, which is dumbbell in shape. We have the d orbital, which is clothed shaped or double dumbbell, or double dumbbell, right? Then we have the f orbital, which is complex in shape. So this is the s orbital. This is an example of an s orbital. It is spherical in shape, right? This is the p orbital. It is dumbbell in shape. This is the d orbital, which is clove shaped or double dumbbell. So you can see this double dumbbell here, right? This is a dumbbell shape, and that is the p orbital. So when we have double of this, that will be the d orbital, and this is the f orbital, which is complex in shape, right? So again, hybridization is the mixing of atomic orbitals of the same atom to form new equivalent orbitals called hybrid orbitals. And like I said, the reason for this is to attain a maximum separation of the electrons, which will give that molecule stability. Hybridization is what is responsible for bond formation in molecules. It is what is responsible for the shape of molecules, the bond angles in molecules, and the bond strength in molecules, right? So, having known this, let's look at the types of hybridization that we have. Basically, we have 5 types of hybridization. We have the sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, and sp3d2 hybridization, right? So the sp hybridization, the shape is linear and the bond angle is 180 degrees. In sp2 hybridization, the shape is trigonal planar and the bond angle is what, 120 degrees. In sp3 hybridization, the shape is what, tetrahedral and the bond angle is 109.5 degrees. In sp3d hybridization, the shape is trigonal bipyramidal and the bond angle is 90 and 120 degrees. In sp3d2 hybridization, the shape is octahedral and the bond angle is what, 90 degrees. So all this is very important. This is a very important information. It can be asked in an exam. What is the shape of sp2 hybridization? It is trigonal planar and the bond angle is what, 120 degrees. So the main important thing here is how to determine the hybridization of an atom. How do we determine the hybridization of an atom? So to determine the hybridization of an atom, the first thing that we do is to count the regions of electron density around the atom. To count the regions of electron density around the atom. And those regions of electron density are the bonding pairs and the lone pairs. They include the bonding pairs and the lone pairs. And then after that, we match the number. So it's very important that you should know that hybridization depends on the electron density around the atom. I repeat that again. The hybridization of an atom depends on the electron density around the atom. Very important. So to determine the hybridization of an atom, we count the regions of electron density around the atom, which includes the bonding pairs and the lone pairs, and then we match the numbers. So if the region of electron density around the atom is 2, that will be sp hybridization. That is 1s and 1p. That will give us what? 2. sp orbital. S plus what? P. So if the region of electron density is 3, then that will be sp2 hybridization. If the region of electron density is 4, that will be sp3 hybridization. If the region of electron density is 5, that will be sp3d hybridization. If the region of electron density is 6, that will be sp3d2 hybridization. So this is very important. So let's look at an example here. What is the hybridization of carbon in methane? So the first thing I would want to do here is to draw the structure of methane. Again, the question is, what is the hybridization of carbon in methane? So the first thing I will do is to draw out the structure of methane. So this is methane having 4 sigma bonds from the carbon to hydrogen. So if you look at this structure, we have 4 sigma bond from the carbon attaching to what? Hydrogen. So like I mentioned before, hybridization depends on the electron density around the atom. So when we're looking at the hybridization of carbon in this compound methane, we are looking at the electron density around this carbon atom. So we can see that there are 4 sigma bonds attached to this carbon, right? So in this compound, there are 4 carbon to hydrogen what? Single bonds. There are 4 carbon to hydrogen single bonds, and this represents 4 regions. It represents 4 regions of electron density. It represents 4 regions of electron density. So 4 regions of electron density, if we match that with what we have, will be equal to what? sp3 hybridization, right? 3p, 1s, 3p and s, right? 3p orbitals and s orbital. That will give us the sp3 hybridization, right? So what will be the shape of this molecule? The shape will be what? Tetrahedral. And the bond angle will be what? 109.5 degrees. So you can see that the shape of this molecule is what? Tetrahedral. And the bond angle is what? The bond angle is 109.5 degrees, right? So that is that for the hybridization of carbon in what? Methane. So let's look at another example for more understanding. What is the hybridization of carbon in ethene? What is the hybridization of carbon in ethene? So ethene has a pi bond between the two carbons. So this is ethene, right? We have hydrogen here, we have hydrogen here, we have hydrogen here, and then we have what? Hydrogen here. This is the structure of what? Ethene. So the next thing I will do is to count the regions of electron around this carbon. I can take any of the carbon. I can take this, I can take this, right? Where we are asked to look for the hybridization of carbon in ethene. So if I go with this carbon, I will have to look for the electron density, or to count the regions of electron around this carbon, right? So if we look at this carbon, there are two carbon to hydrogen single bonds. So in this structure, there are two carbon to what? Hydrogen single bond. Single bond. And that is equal to what? That is equivalent to two regions. That is equal to two regions of what? Two regions of electron density. That is equal to two regions of electron density. And then we have a one carbon to carbon pi bond or double bond, right? So in this structure, there is one carbon to carbon double bond, right? Or pi bond. And that is equivalent to one region of electron density, right? That is equal to one region of electron density. So in total, we have, this is 2, right? So 2 plus 1 will give us 3. So in total, we have three regions. We have three regions of what? Of electron density. And those three regions of electron density is equal to what? What hybridization? It is equal to sp2 hybridization. P orbital, two p orbitals, one s orbital. Two p orbitals, one s orbital. So that will give us three. That's a total of 3, right? So the hybridization is what? sp2 hybridization. And what will be the shape of this molecule? The shape of this molecule will be trigonal. And the bond angle will be what? 120 degrees, right? So the bond angle here is what? 120 degrees. The bond angle here is 120 degrees. The bond angle here is what? 120 degrees. So however you want to take it. So the bond angle is 120 degrees. The shape is trigonal, and it is what? sp2 hybridization. So if we go back to what we have before, it is sp2 hybridization, right? So that tells us that the shape is what? Trigonal. trigonal planar or trigonal in shape, and the bond angle is what? 120 degrees, right? So that's that for 18. So let's look at the last example that we have here. What is the hybridization of carbon in ethane? What is the hybridization of carbon in ethane? So the first thing I would want to do here is to draw the structure of ethane. So this is ethane with a triple bond, right? This is hydrogen, and this is what? Hydrogen. Remember, there must be 4 electrons around what? Carbon. 1, 2, 3, 4, right? So we are asked to look for the hybridization of carbon in ethane, right? So if I take this carbon, I would have to look for the electron density, the region of electron density around this carbon. Remember, hybridization depends on what? The electron density. The hybridization of an atom depends on the electron density around that atom. So the hybridization of carbon in this compound depends on the region of electron density around this carbon. So if you look at this carbon, there is one carbon to hydrogen what? Single bond. So that is equal to one region. That is equal to one region of what? Of electron density. Then, if you look at this carbon again, there is one carbon to carbon triple bond. So there is one carbon to carbon what? Triple bond. And that is equivalent to one region of electron density. So that will be a total, that will result in a total of 1 plus 1 will give us 2, right? So that will give us 2 regions, a total of 2 regions of electron density, right? 1 plus 1, one region plus 1 region will give us a total of 2 regions of electron density. And 2 regions of electron density will be equal to what form of hybridization? It will be equal to the sp hybridization. sp hybridization. And what will be the bond angle? The bond angle is 180 degrees. And the shape of this molecule should be what? Linear. So the total region of electron density is 2. That will give rise to the sp hybridization. And the bond angle is 180 degrees. And the shape of the molecule will be linear, right? So the bond angle is what? 180 degrees. Bond angle is what? 180 degrees. Bond angle is what? 180 degrees. However I want to take it, bond angle is 180 degrees, right? So that is that for the hybridization of carbon in ethane. So to determine the hybridization of an atom, what we do is to count the regions of electron density around the atom, right? And that involves the bonding pairs and the lone pairs. So if the region of electron density is 2, that will be sp hybridization. If the region of electron density is 3, that will be sp2 hybridization. If the region of electron density is 4, that will be sp3 hybridization. If the region of electron density is 5, that will be sp3d hybridization. And if the region of electron density is 6, that will be sp3d2 hybridization, right? So sp hybridization is linear in shape. The bond angle is 180 degrees. sp2 hybridization is trigonal planar in shape. The bond angle is what? 120 degrees. sp3 hybridization is tetrahedral in shape. The bond angle is 109.5 degrees. sp3d hybridization is trigonal bipyramidal in shape, and the bond angle is 90 degrees and 120 degrees. sp3d2 hybridization is octahedral in shape and the bond angle is what? 90 degrees. So this table is very important. So you need to cram everything that is here. You need to understand everything that is here. So with this, we come to the end of this video. In the next video, we'll look at more example for more understanding. Thank you very much for listening. See you in the next video.